John Blichmann and Chris White join me this week to discuss experiments in pressure fermenting beer. This is BeerSmith Podcast number 163. This is BeerSmith Podcast number 163, and it's early January 2018. Chris White and John Blichmann join me to discuss experiments in the analysis of pressure-fermented beer. Thank you to this week's sponsors, Craft Beer and Brewing magazine. They have a great online platform at learn.beerandbrewing.com, where you can take a wide variety of online courses in brewing. They have an offer code, BeerSmith2017, that gives you 20% off when you sign up for any of their online courses. Learn more about brewing at learn.beerandbrewing.com. And also the new Brew Vision thermometer from Blichmann Engineering. This interactive wireless digital thermometer connects right to your iPhone or iPad and lets you remotely monitor and record temperatures. You can download your recipes right from the BeerSmith cloud and set updates and alerts as you brew. Get the Brew Vision Bluetooth thermometer today, another great innovation from BlichmannEngineering.com. Again, that's BlichmannEngineering.com. And finally, BeerSmith software, the industry standard for home and professional brewers, that lets you design great beer recipes and brew with confidence. Download your free 21-day trial from BeerSmith.com today. And now let's jump into this week's episode. Today on the show, I welcome Chris White and John Blichmann. Dr. Chris White is president and CEO of White Labs, a premier supplier of home and commercial yeast. Chris is also co-author of the Yeast Book from Brewers Publications and a 2013 winner of the AHA Governing Committee Award. John Blichmann is president and CEO of Blichmann Engineering, provider of a top line of home equipment for professional, home and professional brewing equipment, I should say. John also writes for Brew Your Own magazine and has created a variety of home and professional brewing innovative tools. It's great to have you guys on the show. Chris, it's nice to have you here, man.
Thank you. Looking forward to it. It's great to be here.
I'm shocked you're home, honestly, because you're always on the road somewhere.
Yeah, well, we scheduled this well enough in advance, so yeah. I'm always home a little bit.
And John, it's great to have you back on the show as well.
Yeah, it's great to be here. I'm kind of snowed in, so what better thing to do with my time than talk about beer with Brad Smith and Chris White? Yeah,
well, we're on, both coasts and kind of in the middle too, I think, right? Because Chris is coming to us from sunny San Diego, and John is in Indiana, right?
That's right.
Well, it's great to have you guys here. Well, I invited you both to discuss your joint experiment into pressure fermentation, which started, I think, probably well over a year ago. And John, I think you actually started out pursuing the idea when you came out with your cornical keg, which does allow pressure fermentation. And I know other people have played with it a little bit in traditional kegs. Can you tell us a little bit about how you came up with this idea?
Well, I originally, I just ran across a paper somewhere that talked about ester suppression with pressure. And I thought, well, that's kind of interesting. And I'd known some people that had done some fermentation in kegs, not necessarily under pressure, but they were doing them just to ferment in a keg as an inexpensive fermenter. And, just kind of had the idea of being able to, for other reasons, make a cone-bottomed vessel that would dual as a keg, and also allow you to do pressure fermentations. And that's really where we developed the cornical fermenter. So it's not only it's got a removable bottom, so you can use the conical bottom as a traditional fermenter. It'll handle the pressure of a keg, so up to 50 psi. But you can then release the pressure, flip it over, and put the keg bottom on, and then you're in your keg. So it kind of gives you those options. If you want to use all of them, you can. But so that's where I really got the idea of, what can I do to validate that this indeed is the case, that you can make a beer with lower ester levels at higher or room temperature, ale temperatures, and use that basically to try to emulate or simulate a lager type beer, but done at room temperature without having to do the temperature control.
So to help folks visualize this, I think you're talking about the traditional, corny keg. Basically, it's a corny keg type thing, where you can remove the top and then replace it with a conical end, right? That you then flip the thing over and you can ferment right there, right?
Right. Mm-hmm.
Yeah. And Chris, go ahead. I'm sorry.
Yeah, go ahead. Sorry.
Oh, I was going to ask Chris. Chris, so you're interested in finding ways to reduce esters in ale, and somehow you got involved in this experiment as well, right?
Yeah, it's there's people have been talking about it for a long time. This is the first equipment that I know of for homebrewers that has been made that you can do this at. Commercial brewers have been talking about it for a long time, and a lot of European brewers, where lager brewing is more widespread by a number of breweries, seems to be taught more as a technique. So one of these strains I had acquired when actively collecting strains and starting up White Labs was yeast, a lager yeast that could grow could ferment very well at higher pressures. And I was talking to a brewer in the late 90s, I think it was, who was really nervous because he had got this contract to sell a beer at this minor league baseball stadium. Mm-hmm. And they wanted a lager, and he'd never made a lager, and he only had a few weeks to do it. And he promised that he would have the beer. So we were talking about that. I mean, what could he do? I said, well, you could try this yeast we call high-pressure lager yeast. I don't have much experience with it yet, but you could try it and see if you could ferment at ale temperatures, go a lot faster, and make this lager. Well, it was successful. He liked the beer, and he continued to sell the beer at that minor league stadium. And so more and more people have used it since then. It's just, but not with, still not very widespread, but it does work, and I could go through some of that biology too if you want, or.
Yeah, I was interested in, maybe you could explain some of the differences between a lager flavor profile and an ale flavor profile. What's the fundamental differences there in the profile you'd see from the yeast?
Yeah, well, there are two different species, which is one thing, right? So Saccharomyces cerevisiae versus Saccharomyces pastorianus. And Saccharomyces cerevisiae is the ale yeast. And so they share a lot of DNA, but they also have some different DNA, and mostly in amino acid metabolism, which is where a lot of flavor compounds come from, including esters. So the ale yeast, so there's that biological difference of different amino acid pathways and metabolism, but then there are also, those pathways are temperature dependent. So traditionally lagers are fermented cooler temperature, which represses growth, right? Less growth, you're going to make less of all of that metabolism. You're going to make less esters. So lagers typically have less esters than ales, mostly because of that lower fermentation temperature, combined with some different pathways. For example, lager yeast make sulfur because of the difference in again, that amino acid metabolism. But they also do different esters and things. So it's a combination, but it's if we focus mostly on the temperature, it's that lower temperature that you get 2 or 3-fold yeast growth with lagers, and 5 or so fold growth with ales. Now, another way to suppress growth is by putting a little pressure on those cells. That reduces their growth, just like reducing temperature would reduce their growth. It puts a stress on them. So as you ramp up the temperature, eventually they're going to blow up, right? They're going to die. But there's a temperature, around 1 bar, 15 psi, that is kind of known that yeast will still be alive, but they'll really grow kind of slowly, more at that.
I'm sorry, you mean pressure, right? You said temperature.
Sorry, pressure. Yeah.
Yeah. So around 1 bar, you said it grows. The growth is suppressed, right?
Right.
And then when we talk about esters, what flavors are we talking about? What flavors are associated with esters for folks that may not be familiar with that?
Fruitiness, basically. So there's 30 or so important esters, but they make the fruitiness in beer. So there's the fusel alcohols. And those are all the other kinds of alcohol besides ethanol. And then those combine with acids to make esters. And so instead of having alcohol, these esters have more fruity, perfumey characters. It could be fruitiness like banana and apple, just a variety of all of that fruity aroma. And that's one of the big difference between ales. They have that fruity character.
I think one of the big ones is ethyl acetate. I think is pear flavored, right? The major one.
Ethyl acetate is kind of one of the bad ones, but it takes a lot of it to get it. Ethyl acetate is kind of nail polish remover.
Right, when you get to the really high concentrations, but at the lower levels, you get more of a pear flavor. And what role do these esters play in developing the traditional lager profile and the traditional ale profile?
Yeah, they're still there. The esters are still there in lagers. When I started in, there was less, obviously, commercial craft breweries, and it was the big brewers, and there was the big brewers going to master brewers meetings and stuff. They would talk about the different ester levels in Bud Light versus Miller Light versus Coors Light and things like that. So, we as craft brewers and home brewers are talking about it so differently because we have a lot more flavors in our beers. But even in those beers, you take out the esters and you have cardboard, so you have a really bland flavor because barley doesn't have much fruitiness and they don't have enough hops to have any flavor. So it's really the whole spectrum of beers need fruitiness. Wine starts with a fruit, with grapes. So they've got a natural built-in fruitiness already that yeast adds to. But beer has to develop all of that from the yeast.
Makes sense. So whether you make it a lager or an ale, you're going to have some esters there. It's just a level that varies between the two, right?
Correct.
Now, are there other differences in flavor profiles between a lager and an ale? Obviously, probably so, right?
Yeah, certainly the sulfur levels are higher in lagers, fermentations.
That's kind of that rotten egg smell I get when I make a lager, right?
Yep. And again, from amino acid metabolism, a couple of those amino acids are sulfur containing. So as they move that sulfur around to make those amino acids, it's just a little bit different in the Saccharomyces pastorianus versus cerevisiae.
Mm-hmm. Well, John, I was going to switch over. John, did you did some research that indicated that large commercial breweries actually ran into this pressure fermentation problem kind of inadvertently when they started fermenting in very tall fermenters, right?
Yeah, I seem to remember on a visit up to Bell's Brewery, they had installed some at least 2-story tall fermenters. They're extremely tall, and they were saying they had to adjust some of their hopping rates, I believe, and also some of their temperature rates because of the large static pressure. So up at the very top of the vessel, it would be, pretty much 0 bar, and then down at the bottom, if you're every 2 feet is 1 psi. So, if you've got a 30-foot tall fermenter, you're at about 15 psi at the bottom. So they were just mentioning they had some things to do due to the geometry of their fermenters to get the beer to taste the way it did in the shorter ones.
So I mean, the commercial brewers have had to struggle with this problem, I guess, right?
Yeah, that's that's my understanding from that, and then just some of that that white paper I ran into a number of years ago. So just got the curiosity up in me, and just thought, geez, if there'd be a way to get something fairly close that could help out a lot of brewers with. Without the ability or the desire to buy some cooling equipment for their fermentation. So
right. Well, Chris, can you tell us a little bit about the biochemistry or changes going on when you actually apply pressure to a yeast cell? What happens internally?
Well, that pressure on everything about metabolism is flow into and outside of the cell, and they're just made of these fatty acids, lipids. So that makes that kind of oily layer with water on one side and water on the inside. And then there's protein stuck in there for a lot of the trafficking. So products have to come in and out. Even though the yeast is making amino acids, they're bringing amino acids in from the wort. That's why you need well-modified malt. And they are bringing in things like zinc and, of course, all the carbohydrates, glucose, and so on. So those got to come in, and then ethanol and CO2 and these esters that we're going to want to taste in our beer, they're going to have to go outside of the cell. So all of that trafficking is going to be different at atmospheric pressure and then other pressures. So as you get higher pressure, it changes, and that puts more instability on the cell. So they'll either not import the products the same, or even if they make the same amount of ethanol, for example, they might not export them.
So it stresses the yeast cell and makes it more difficult for it to control the flow through the wall. Is that what you're saying?
Exactly.
Yeah. And that has the effect of what on the finished beer, I guess?
Well, yeast and yeast react to that like they would temperature. You know, when there's lower temperature, they change the metabolism a little bit to try to do survival. Same thing with pressure. You know, the cells are biologically kind of there to know that, you know, other genes have to be turned on to, say, protect the cell wall, which might sacrifice from flavor compounds being made. And in this case, we might want a few less flavor compounds. So that's why usually you have to go to these lower temperatures and lagers to suppress that growth. But this is another way to do it, but not killing the cell.
I mean, can you actually apply pressure to the point where it does kill the cell?
Yeah, see, we always recommend stay away from anything over 15 psi. Like, that's a pretty safe number. We've done experiments where we've done higher pressures, and you look at cell damage and cell death. So that's always been what we have recommended up until now, without any other kind of evidence. But saying you're pretty safe up to 15 psi, and since beer gets carbonated at that pressure, and that's a pretty normal value we have a lot of experience already with yeast surviving that pressure.
And it's pretty obvious, I guess, when you carbonate a bottle, when you naturally carbonate a bottle, obviously you're doing pressure fermentation, right?
Exactly. Yeah.
You're just not using it for the primary flavor compounds of the beer. You're just it's more of an accent at that point, I would imagine, right?
Right.
Yeah.
Right. And there's very little flavor contribution here anyway, because it doesn't get through much growth, and you know, who knows, the pressure might have something to do with that. But for example, you can use, we've done experiments where we've used like wheat beer strains in lagers or pale ales just for the carbonation, and you don't taste the phenol.
Interesting. Well, how are you controlling the phenols? Are the sort of the banana clove flavor, right?
Yeah, that real clove, spicy character. But they just don't get made, you know, because the yeast isn't really growing much in the bottle conditioning. Same thing with any kind of carbonation conditioning, such as champagne and other things. There's not much cell growth that happens there. So it's always about that. Less cell growth leads to less flavor compounds.
Right. Well, John, you worked with Chris to design an experiment to quantitatively measure the changes in the yeast flavor when fermenting under pressure. Can you tell us a little bit about your experiment and your setup?
Yeah, sure can. We really set the thing up to try to simulate as much as we could the a very even pressure and a very even temperature between them. So what I did is I brewed a single 20-gallon batch of a Munich Helles. We went with a fairly neutral flavored beer so that we could perceive those esters versus like trying to do, you know, something that had, a lot of hops in it, for example. And they went into 4 individual cornical fermenters. So the fermentation geometry was identical. And then we fitted those with what they call a spunding valve, or it basically just a pressure regulator. I think there was a recent article in Brew magazine on making a spunding valve. So the one we used was a pretty precise pressure regulator, and it was able to keep it within, during fermentation within about a PSI of that. So we ran the control was a lager done at the traditional lager fermentation process and temperatures. Chris was kind enough to send us yeast. I don't personally have the yeast cell counting equipment, and Chris sent us the yeast, enough yeast for 4 individual fermenters. I think it was 4 of the pure pitch tubes, and it was the 833 yeast that we used, and that got pitched into each of those 4 fermenters, and then the pressure was set. There were one was going. I have 2 upright freezers in my basement at home. And one I used for the lager temperature profile, and then the other I had the other 3 fermenters in and set it at 68 degrees, and one at 0 bar, one at 1 bar, and one at 2 bar, and then let them ferment out. Of course, I oxygenated using an oxygen wand with pure oxygen for the exact same amount of time. So I try to make each batch with the minimal amount of variation in them. So it was just the pressure and the temperature. So that's how we did the result, and then I let them ferment out. And after that, we did a tasting panel. It just happened to be right around the time of the Indiana State Fair. So we had a number of pretty highly ranked judges, including Gordon Strong, that was there, and we did a blind tasting on those. Cool. And yeah, go ahead.
I was going to say we'll talk about that in just a second.
Sure.
But yeah, so basically you made one big batch of beer, right?
Right.
And then you split it into 4 and fermented one of them at lager temperatures, and then the other 3 you fermented at different pressures, right?
Right. Room temperature, 68 degrees, and 3 different pressures, 0, 1, and 2 bar. So 0, 15 PSI roughly, and 30 PSI. And
then I think you sent, the next thing you did, you actually sent samples to Chris to do laboratory analysis on, right?
That is right. So we tried to do a qualitative analysis, which was the tasting. And there's been others that have done that, but most people don't happen to have mass specs in their basement. So Chris was, I had met or talked to Chris about this whole experiment at some event that we were at. I forget which one it was. And he said, yeah, just reach out to me. And he provided the yeast, and then I sent the samples to him, a couple bottles of each. And he ran them through his mass spec and got tons of data for us.
And Chris, you followed up by doing the laboratory analysis. Can you tell us a little bit about the analysis you did? And I do have, John sent me, I know you can't see the charts right now, but John sent me 3 charts on, one of them is ethyl acetate, one of them's diacetyl, and one of them's isoamyl. So maybe I can bring those up as you're talking about it. But can you talk a little bit about the results you found?
Yeah. So it was fun because we got to do, we did the sensory as well, and we're able to pick out some of the differences. And it was nice that it was, 1 bar and 2. So we had, 0, 1, and 2, and being unlabeled. When they were delivered to us, it was fun for me to go through that experiment and then look at the data. These are all gas chromatograph experiments, and see how they compare with some of the other tasting notes. So there are some things like pretty normal, like alcohol and so on. You're looking at those esters as the main.
Well, the three graphs that I have here are ethyl acetate, diacetyl, but feel free to talk about any of the results, Chris.
Okay. Yeah, they were all pretty similar in terms of the other specifics. Specific gravities all ending at 1.009, 1009. 5%, 0.1 or 0.11 alcohol by volume. And so from an analytical perspective, these the 2 different pressures and 0 all made a pretty equivalent beer in looking at attenuation.
Right.
Diacetyl all were around 10 ppb after aging, so that was good.
Yep. So except for the lager, looks like the lager actually had a higher diacetyl level, right?
Yeah. Below 50 is still considered the safe number, ppb, for not tasting diacetyl.
So 0 to 50 is acceptable then, huh?
Correct. Yeah.
And I'm looking at the diacetyl numbers here.
That has a little bit more, but it's still under flavor threshold.
Okay.
And then the esters, we have ethyl acetate, ethyl butyrate, isoamyl acetate, and isobutyl acetate, but we couldn't detect anything there. And the one we were talking about before, ethyl acetate, went from 33, 40, 23, and 19.
Right.
So the 23 and 19 are the 1 and 2 bar. So it's interesting that, you see, and ethyl acetate is often measured as an ester, even when it's below flavor threshold, to gauge how the ester level is in a beer. So at those higher pressures, ester level is quite reduced.
In fact, it's for the 1 and 2 bar, it's less than it is for the lager, it looks like, the lager temperature one.
Exactly.
So it looks like you were successful in suppressing those, at least with this particular yeast strain, right?
Yep. Same with the isoamyl acetate, which is kind of the banana ester. So even again, when it's below flavor threshold, it's still important to see what the level is at. And we've lowered it in the 1 and 2 bar. And again, lower than the lager temperature.
Wow, yeah. So it's lower. You got lower acetates across the board. I'm sorry, lower esters across the board. It looks like, right?
Yeah.
Lower in all cases, even in the lager, right?
Exactly. Yeah.
So kind of a positive result quantitatively, right?
Yeah, it matches what people think about pressure fermentations. It shows that this unit that John made is able to do that pressure fermentation and suppress the esters.
And it looks like the 2 atmosphere actually worked the best overall. Lowest level of esters, lowest level of diacetyl, I think, right?
Which one?
The two atmospheres.
Yeah, the 2 bar.
Yeah.
2 bar. I'm sorry, 2 bar.
Mm-hmm.
Right.
So pretty low.
From an analytical standpoint, yes.
Yeah. So that's pretty good result then, right?
Yeah. I was also pretty impressed with, or kind of surprised how the final gravities pretty much dialed in the same. The attenuations were about the same. I was expecting something different there, that the yeast wouldn't be able to handle it as well and wouldn't maybe attenuate all the way.
Did you see any difference? I don't know how long it took you to do this. Did you see any difference over time? Did you happen to track them over time? Probably not, huh?
I did.
Oh, you did?
I think I have that.
I was wondering if it fermented faster at lower pressure or what.
Not very much. There was a slight difference, but not too much. As I recall, the pressure fermentations were just a little slower than the atmospheric, the 0 bar one.
Interesting.
But they were all quite a bit faster, I believe, than the lager temperature, which also validates part of the reason to do pressure fermentations.
So potentially you could produce a beer a lot faster with pressure fermentation than a traditional lager, right?
Right. So I think I plotted the dates with the specific gravities, and it was, the lager was about 8 weeks, and the ales were done, and this is done filtered and kegged in 2 weeks.
2 weeks versus 8 weeks.
Yeah.
That's pretty substantial. Yeah. Chris, I wanted to ask you, did the pressure fermentation have any other unintended consequences from an analytical perspective? Were you able to find anything bad about pressure fermentation?
No, we weren't. I think that the question to continue would be the health of the yeast. How many repitchings could you do if you like to repitch yeast? Does it have an effect on shelf life if that was important to you? Because of any components maybe from the yeast that might be released if they were unhealthy or dead, especially at the 2 bar. But I think that could be something to look at here in the future.
Mm-hmm. Mm-hmm. But you didn't find anything in the analytic results, right?
Nope.
Well, that's good. Well, John and Chris, I think you were both able to sample the beers, and I'm going to ask John in a minute about what happened at the Indiana State Fair. But what were the two of you? What was your perception of the 4 beers? Let's start with Chris. What did you think of the taste?
Well, it was me and 2 others here, Karen Fortman and Kara Taylor, that did the tasting, and while the analytical data showed them all the same, I think I could tell the difference, which that's good or bad. I think it's interesting. And again, they were not labeled to us, but I felt I could tell the one that was lager temperature versus pressure fermentations because the lager temperature still, to me, had the characteristic sulfur character with the right ester level. And it's interesting that the lower ester levels I just couldn't pick out, and it didn't seem to have that sulfur backing and everything. So they were all good, and but they were a little different. And I think that's kind of cool. And you could probably also dial it in to, say you wanted to taste your ale or your higher fermentation temperature to taste more lager. You might be able to dial that in. Or you wanted your, to use different yeast strains and put pressure on them. You could probably dial it in. But from this experiment, I could also taste the differences.
And we didn't talk about the sulfur levels. Were the sulfur levels markedly different between the 3 beers or 4 beers?
For me, I could taste the differences, yes, in them. It's not something our equipment is not sensitive enough. Sulfur compounds are in such small quantities, so we weren't able to measure it here. But I don't know, John, how you felt about that.
I felt the same way. In fact, even while they were fermenting, you can pick up that sulfur. When I'd open the freezer door to check on pressure, you could smell that the sulfur compounds in the lager freezer, but not in the other one at the room temperature. So I noticed that too, and a number of the other tasters at the Indy State Fair did as well.
Well, let's jump to that. What were the results when you took it to the Indiana State Fair, John?
Of course, you've got the human element in there, but and when we did the tasting, it was, here are 4 beers. It's the same base beer. And something different was done in the process, in the fermentation process. So, I didn't tell them what it was, whether they had no idea if it was a different yeast, if it, temperature, they had, no idea about the pressure, none of that. So they went in judging them like they would, any beer at the competition, and they noticed the same thing with the lager. Most could pick out which one was the lager beer. They noticed the one at 0 bar and room temperature was notably higher ester levels, and the one at 1 bar, they noticed it was cleaner, and then the ale, the room temp or the 0 pressure one, and they also noticed on the higher pressure one that it was the hop bitterness was more pronounced, notably more pronounced, and almost a little bit harsher. I wouldn't say tannic necessarily, but just a little harsher than that. And one taster even noticed that it was just a little, the hops were just a little muddy on the end. In general, they could tell the difference between the 4, and the 15 psi seemed to, or 1 bar, seemed to be the better mix of the pressure fermentations.
Interesting. So they could actually tell the difference between all 4 beers. Were there any general impressions overall? Which one would they want to drink?
And that's the funny thing is, some liked the lager, some liked the 15 psi, the 1 bar, and we had, I think there was one person that liked the balance of the 2 bar beer the best. So that was kind of the results there. And again, you've got the human factor in there, but you'll pick up those things that you can't with an instrument. But then it's also and why, when I was talking with Chris, that I felt it was important to do not only a qualitative analysis, the tasting, but to do a quantitative analysis with instruments that you could really measure things to really, verify what was going on. So it was a fun experiment to do.
And Chris, you mentioned you had a couple friends try it at White Labs as well. What was their overall perceptions?
We all. It was interesting to us because we, as I said, we didn't know the beers, but we did know the premise. So we knew there was, a lager temperature, an ale. So we were also kind of trying to put it into that perspective. And it was fun to talk about it. And it is why sensory is so important, because your senses can pick up so much more than analytical equipment. It's why large breweries still pay humans to do sensory analysis, and the whole food industry does, food and beverage industry. And then so really when we did sensory, it was a mirror of that, because the beers were more different than what the analytical paper kind of shows on paper. I preferred the lagers. I like those styles. I try to judge those styles as much as possible. So there's maybe some bias in there, but it wasn't uniform. Kara and Karen both liked different. I don't remember. I didn't write that part down from their notes, but I think one bar, was kind of another one that one or two of them liked over the lager. So
kind of the sweet spot was one bar then.
Yeah, because it was sort of obvious, which one was more estery, right? So unless you want your lager to taste like ales or something, the 0 bar ale temperature probably wouldn't be too many people's favorites. You could do that today without doing anything different, right? Right? So and it raised the esters but lowered the bitterness, which the IBUs went from 21 in lager to 16.5. Pretty significant, and I think that's just indicative of, we know there's hops and yeast interactions, and you're going to have more of that at higher temperatures. But then it went back to similar to 21 with the 1 and 2 bar. So that pressure, that lowering the fermentation activity, brought that IBU back up again.
So you're saying the IBU level on the lager was significantly lower than the ones that were pressure fermented?
No, it was higher.
Oh, higher. Okay.
21, and then it went down to 16.5 with the 0 bar temperature, and then went back up again to 21 with 1 or 2 bar.
So they were all, so the lager, the 1 and 2 bar were all at 21 then?
Yes.
Interesting.
So I think suppressing that fermentation, brings the hop quality out.
So there's some biotransformations going on there between the hops and the beer itself, I guess, right?
Yeah.
Or the yeast, I should say.
Yeah, there's binding, there's biotransformations, there's the sheer contact with cell walls and what that does. Different types of cells seem to stick to hop material differently. So more growth can just also reduce hop character in certain strains. Mm-hmm. Because there's more now cell walls to stick to the hop material.
So I guess the next question is, John and Chris, do you think we have a viable method here for potentially making a beer a little bit faster, making a lager like beer a little bit faster? I'll start with you, John.
I think you hit on the key word, a lager like beer. You won't make the exact same flavored beer as doing the traditional lager profile. But you can make one that's awful darn close and in much less time and without the temperature control. So, that's a neat thing about homebrewers, homebrewing in particular, is you can experiment and see what you like. And, some future experiments could be, well, what can I do to change a little bit to get it a little bit closer to the lager character? So, that was my takeaway from it. Was it certainly has some good merit, and it produced a lower ester beer at room temperature. So,
and Chris, your thoughts on this?
Well, I think that was a great description of it, and I appreciate that John, in this. We're just looking at these results as these results, where I've worked with other people. If they invent something or make something, they want the data to fit what they just made. Like, oh, they're all the same. Well, they're different, and that's cool. But they tasted different. But it does allow you, and that's maybe important. If you were, say, you want to make some lager and enter it into competition, and it's going to sit next to other lagers with that characteristic those flavors that somebody's expecting in, say, a European lager, this one or maybe not fit, maybe not would not win a medal there. But if you like the flavors and your friends did, and it's not much different if you weren't doing a side by side tasting, right? It gives you a way to, instead of having equipment to cool the temperatures, which is expensive and hard to do, and actually on the small scale fluctuates so much it's sometimes ineffective or causes more problems. By having the pressure, it allows you to make the beer, a lager-like beer, faster, or even an ale a little faster and less ale-like. So I think there's some cool things you can do in there. And fermenting under pressure is another nice little biological trick of reducing potential for contamination. So that's why some breweries do it even just at a few PSI.
Interesting. So what can you explain that aspect of the experiment? I guess I'm not familiar with that, how you reduce contamination.
Well, I'm just throwing it out there as another positive of this system, because a lot of breweries, and especially in the kind of the biotech industry, where you're also fermenting in stainless steel with different microbes, you put a few PSI on the fermenter in order to just have any theoretical of any microbes getting into your vessel. So it's a nice little tool in microbiology, because even though you're thinking, this is a closed vessel, how's anything going to get in there? Microbiology finds a way. It's no such thing really as a closed vessel. There's all those ports and pieces and parts. So by fermenting under a little bit of pressure, that helps from a contamination standpoint. So it's just, I think, another positive feature of this system that even you don't have to go right at 1 bar or 2. I don't know where you have to set it in this equipment, but a little bit of pressure is helpful in a fermentation.
So if I've got 2 weeks to make a lager, this might be a reasonable approach then, right?
Yes.
It worked, yeah, absolutely. Like I said, it worked at that baseball stadium. So that was one of my early experiences with this. But it's not, people weren't going, hey, man, this isn't a lager. I've been fooled by it. It's, like I said, it was really easier for me in a side by side in the experiment too to go, okay, this is the lager fermentation. Mm-hmm. But I've gone into breweries where they've given me samples of their lager, and I've said, oh, that's a nice lager, and fermented like this.
Interesting. Well, John, have you guys thought about where you want to go next with this?
Yeah, I was actually thinking about trying some ales at elevated temperatures to see what can happen there. One other thing that I did notice.
I'm sorry, elevated temperatures or pressures? I'm trying to.
At pressure, but elevated temperatures to see, if you could, how fast you could ferment something. I'm never in that big of a hurry. I'm one of these people that can lay up a wine for a couple years and not taste it and be okay with that. And there's others that would drive me absolutely crazy. But so it would just be an interesting thing to do to see if I were to ferment a beer in the 80s, if you could make that taste very similar to a beer that's just fermented at in the mid to high 60s. Just for a fun experiment.
So you're saying take an ale and ferment it at a very high temperature, and you're not worried about sulfurs at that point, right? So you're potentially just trying to suppress the ester production and the fusel production, right?
Right. Try not to make an unintentional banana clove bomb.
Yeah. And what do you think?
That'd be a great experiment.
Do you think that's a good experiment too, Chris?
Yeah, you want faster, raise the temperature. Well, you can't really raise the temperature normally because you're going to have all these flavors you don't want. But if the pressure suppresses that, there you go.
Interesting. So another question I had on just in general was on pitch rates. Did you how much yeast did you decide to pitch? Did you end up pitching more yeast because you were fermenting at pressure and suppressing growth, John?
I pitched 4 of the pure pitch packs into each fermenter. So I forget what the cell count was there, Chris.
So that's more like a lager pitch rate, right? That's a higher pitch rate, I think, right?
Right.
Yeah.
Mm-hmm.
Yeah.
Okay.
So that way the pitching rate, we're choosing the one you needed for the lager because it was fermented from the beginning at lager temperatures, but then making sure having that pitch rate the same in all of the beers for this experiment.
So that gave you plenty.
And that could be yet another experiment, is to run it with an ale pitch rate and see how that compared.
Yeah.
So, again, I was just trying to change the minimum amount of variables at once so we could really attribute it to, yes, that was pressure.
Right, and that could be important if you're buying that yeast. You might say, well, the one advantage of this is you don't have to buy those four. You buy that one, and not have to do a starter perhaps too. So,
right. Mm-hmm.
Interesting.
So there's another cool angle of this that could be explored.
Looks like I got to do another experiment, Chris.
Yeah, happy to help.
And Chris, I want to get your closing thoughts. Where do you think this might go next?
Well, I hope there's more interesting fermenters made for home brewers. The commercial industry uses open fermenters. They use squatty ones. They use different ones. And in home brewing, it was mostly the glass carboy. And then obviously there's a bunch of new things now. But some of these designs, I think, could have an impact on flavor chemistry. And I would like to see that explored more. And this seems like a nice start.
And John, you're an equipment manufacturer. What are your thoughts on that?
It's funny because a lot of times I just come up with these products so I can have it at home to brew with.
Yeah. Well, at Cortical, I think you're working on some new fermenters too, aren't you?
Oh, we're always working on new stuff.
Yeah.
I would love to see an open fermenter. I think they're so great for Belgian style beers, Hefeweizens, even, the old ales, and homebrewers if you could skim off the top in a couple of days and get some good yeast off the top and then put a lid down again that allows you to even clean it better. I think that would be really nice.
Probably do that in a bucket, can't you?
Well, that's not very elegant, is it?
You got a nice stainless steel bucket, don't you, John?
Yeah, we do. Yeah, we do. I started in plastic buckets, just like everybody. Made some pretty good beer.
I still make some mead and wine in plastic buckets. Not any beer anymore, but yeah. Okay. I really appreciate you guys both coming on the show. Thanks for being here. Any final thoughts? I guess, Chris, let's go with you first.
Looking forward to 2018.
Are you?
Yeah.
You guys got anything exciting coming up? White Labs?
The three of us are all doing those brew your own classes again.
That's true. I'll put in a pitch for the brew your own event coming up in less than a month now. At the beginning of February, right? February 2nd and 3rd, I think. And you guys are both teaching classes. Chris, I'll let you talk about yours.
Yeah, I do a yeast fermentation class all day, and going through from the beginning of the discovery of yeast and why that still is important to a commercial or home brewer, anybody brewing, to lab techniques, with trying to just the information that allows you, I think, to make better beer when you know more about yeast. So I do a full day, and I hope we keep doing them after the San Diego one. This will be the 4th, I believe.
I think that's right.
That's right. Yeah. And John, you're giving a seminar with John Palmer, I think, right?
That's right. We're doing introduction or intermediate all grain brewing. So we're actually gonna the two of us are gonna go through the basics of mashing and how you can change variables around to change the flavor of your beer. And we'll go from everything from and these are live demos. We're actually going to brew 3 different batches at the same time. It's quite a feat, but we pulled it off. And we'll do a brew in a bag. We'll do one in a Brew Easy system, and then we'll do a traditional fly sparge using a single infusion. And we'll just you can see the different processes, the different things. Learn about water chemistry and mash pH. And it's a really great environment. They limit the class size to 35 people, and we're all in the same room all day long. So it's about a 7-hour seminar, I think, and it's located in sunny San Diego this year.
Chris's hometown, right?
Yeah.
Yeah, and I'll be doing a session on recipe design. Will be a big focus on ingredients, but we'll be doing ingredients, troubleshooting, off flavor testing, all kinds of interesting stuff, and I'll be doing that both days. So you can pick either day if you want to attend. I'll mention, again, plug it, is February 2nd through 3rd in San Diego, and it's Brew Your Own sponsoring the event. So if you look up BYO San Diego, if you Google that, I think you'll find the sign up, and the registrations are still open for a little while, and we'll all be there, right? Chris will be there, and John will be there.
That's right.
It'll be exciting.
John, you can sign up for just one day as well.
Yeah, you can. John said you can sign up for one day as well. So if you're interested in just one seminar, you can go for one day. It's a Friday and a Saturday. So there. John, you got any other closing thoughts on the experiment?
It was just fun to have an experiment like that and be able to work with Chris on some of the analytical part. I learned a bunch, so that's always good. And I appreciate you having us on the show to share this with all the viewers and spread that knowledge out to everybody else that we learned.
Well, I'd like to thank both of you for coming on the show again. Chris, it's great to have you here. Pleasure.
Thank you.
Chris White. And the one and only John Blichmann, my good friend John. Great to have you on the show.
Good to be here.
So again, my guests today were Dr. Chris White. He's president and CEO of White Labs, as well as from Blichmann Engineering, the CEO, Mr. John Blichmann. Great to have you guys. Thanks again.
Thanks.
Yep, our pleasure.
Well, a big thank you to Chris White and John Blichmann for joining me this week. Thanks also to Craft Beer and Brewing Magazine. Their educational program lets you learn about every aspect of brewing in detail. Take advantage of their fantastic sale and get 20% off any of their courses when you use the offer code BeerSmith2017 at learn.beerandbrewing.com. Again, that's BeerSmith2017 at learn.beerandbrewing.com. And also Blichmann Engineering, creators of the innovative new Brew Vision wireless thermometer. Remotely monitor your brewing system from your iPhone or iPad, record data, set alerts, and grab recipes directly from BeerSmith. The Brew Vision thermometer, another great innovation from BlichmannEngineering.com. And finally, BeerSmith software, the industry standard for home and professional brewers, lets you design great beer recipes and brew with confidence. Download your free 21-day trial from BeerSmith.com today. Thank you for listening. I hope you have a great brewing week.